Welcome back, everyone. Today we're going to be finding all the roots with multiplicity of the following polynomials, and we're going to do two examples today. Now, when we say all roots, we mean all roots, including potentially imaginary or roots or complex roots. So for this one here, you might notice that we already can tell what two of the roots are. We can already tell from this factor here, the x plus 2 to the power 4, that we have a root of x equals negative 2 with multiplicity of 4. And then from this factor here, we can tell that we have a root of x equals 3 with multiplicity of 2. Now, what about this factor here? Well, with this factor here, we know that it's a quadratic, so therefore it must have exactly two roots or one root with multiplicity 2. Now, those roots could be imaginary or real. We don't know yet, right? It just depends. I think in grade 9 in Algebra 1, we learned that every quadratic equation had either 0 roots, 1 root, or 2, but those are only talking about the real roots. The actual possibilities, as we know them now, are there could be 2 real roots, or 2 imaginary roots, or 1 real root with multiplicity 2. Those are the options. So in this case here, looks like we can factor this by inspection pretty easily. We can note that 2 times 3 is 6, and 2 plus 3 is 5. So this can just be x plus 2 times x plus 3, and then x minus 3 squared is still here. X plus 2 to the power 4 is still here. Now there's something else I'm noticing right now too. Here we have an extra x plus 2, and x plus 2 times x plus 2 to the power 4 is the same as x plus 2 to the power 5. So actually, the root negative 2 that before we believed had multiplicity of 4 actually has multiplicity of 5. And then now we have a new root as well with just multiplicity 1, which is the root that comes from x plus 3 right over here. That's going to be negative 3. So we also have a root of x equals negative 3 with multiplicity 1. So in this case, we actually did not have any complex roots. Okay, let's try the next one. So for the next one, already we can tell that we have a root of x equals to negative 7 with at least multiplicity of 3 as far as we can tell. If it turns out to be more later, we can switch it later. Then over here, we have a root of x equals 5 with multiplicity at least 2, so we'll put 2 for now. And then we have this quadratic in the middle here. So something I noticed right away about this quadratic is we can factor out a 2 from it. So this would be 2 times x squared minus 4x plus 3. And then I'm just going to repeat the x plus 7 cubed times x minus 5 squared. Then what we're going to do is we're going to note that x squared minus 4x plus 3, well, negative 3 times negative 1 is equal to 3, and negative 3 plus negative 1 is negative 4. So this can just be turned into x minus 3 times x minus 1. And so in addition to the roots that we already had, we now also have x equals 3 and x equals 1, multiplicity of 1 for each of them because there's no power on these factors other than just 1. So there we go. Now let's say we weren't able to factor that quadratic. Well, if that were the case, we would use the quadratic formula in order to figure out the solutions, and we may end up with some imaginary solutions as well, right? We may end up with complex solutions, and those should still be noted as solutions in Algebra 2.